Hello Garden Fields Lockfest 2020. I'm Emma from Fab Science, and normally we come along and visit Garden Fields every holiday to bring you all sorts of fun science stuff, but this year unfortunately we can't, so I'm coming along to your online festival instead. Now I'm going to show you some stuff about amazing air, and my first question to you is, do you think you're really strong? That's a bit of a rubbish question, isn't it? Because how strong is strong? So I'm going to start off with something easy. So firstly, put your hand up if you think you are strong enough to pick up a teeny tiny marshmallow. Now I'm pretty sure everybody's got their hands up right now. You can all pick that up because it's really, really light and really, really easy to pick up. Okay, hands up if you think you are strong enough to pick up an apple. Bit heavier, but I think everybody's still fine with that. Now what about all 7 Harry Potter books? Now that's quite heavy. But I bet some of you have still got your hands up that you reckon you could pick up all of those books. Now, this is the biggie. Can you put your hand up if you think you are strong enough to pick up an elephant? Now, I bet that some of you watching this at home have actually got your hands up right now and you're telling me that you're strong enough to pick up an elephant. And you probably think you're being a bit silly by doing that. But you know what? You've actually got a really good point. Because right now, you are carrying around something which is as heavy as an elephant. And so am I. And do you know what that is? It's just air. Now, if you put your hands above your head and wave them around like you just don't care, you can feel that air above your head. But I'm saying that air is really heavy. And air's not really heavy, is it? You can fill up a balloon, you can still throw it into the air. But we haven't just got a little bit of air on top of our heads. There's actually air here and here and here and here, all the way to the edge of space. Now that's a lot of air. And even though a little bit of air only weighs a little bit, a lot of air weighs a lot. Now I'm going to show you something with this air pressing down on us. And I'm going to show you with this can. Now I'm just going to pop a little bit of water in the can before I start. And then what I'm going to do is I'm going to heat up the air inside the can. And when we heat up the air, all the little particles that air is made of, they start to jiggle about faster and faster and faster, and they move apart, and that makes the air expand, so it gets bigger and bigger and bigger. And then when we leave it to cool down, it's going to get smaller and smaller and smaller. So I'm going to heat up the air in here. So right now, the air in here is getting bigger and bigger and bigger. So it can't all fit inside the can anymore, so some of it has to escape out of the top. Now we put a little bit of water in there, and don't really need the water, it's just to show us when it's nice and hot. Because hot air just looks like air, doesn't it? We wouldn't be able to tell. But because we've got the water, we should be able to see when it starts to turn to steam, and that will tell us that the air is hot enough and we're ready for the next bit. Because what we're going to do when the air has got hotter and hotter and bigger and escaped out of the top, we're then going to cool it down. When we cool it down, it gets smaller and smaller. And we're going to cool it down quite fast by putting it into some cold water. So when the air on the inside gets smaller, all this air that's pressing down on us and pressing down on the can actually squash the can. Now, do we think we're ready? So, after 3, I'm going to turn this upside down, put it in the cold water, and you can see that air pressure in action when it squashes the can. You ready? 1, 2, 3. Whoa, look at that! The air on the outside around me in the room has just completely crushed that can. So we've just seen what air pressure could do to this can. It just completely crushed it. And I want to look at what air pressure can do now with that little marshmallow we were looking at. Now, I'd like to make this marshmallow bigger. Now, one way I could do this is actually if I heated it up, the air inside it would get bigger and bigger and bigger, and it would grow. And that's something you can try at home. If you get a big marshmallow, stick it on a plate, get a grown-up to help you, put it in the microwave for about 20 seconds, and you'll see it start to grow. But there's actually another way we can make it grow without having to heat it up. Because we've got air inside this marshmallow and air on the outside, and they're balanced at the moment. But if we put more air on the inside, then it would grow, wouldn't it? So we could try pumping air into the marshmallow. Do you think this is going to work? that doesn't really work. I'm afraid you can't pump air into a marshmallow. So we can't put more air inside it, but what if we took away the air from the outside? Then the air on the inside would have more space to spread out and grow. Now I can't do that in the whole room because I'd have to take all the air out of the room and then I'd have a bit of a problem breathing. But what I can do is if I have some marshmallows in a bottle like this, I can actually pump the air out of the bottle, and then that gives that air on the inside of the marshmallow more room to spread out, and they should start to grow. So you need to watch very carefully. So I've got here a special lid called a valve that will let the air out without letting it go back in again. And then this is a vacuum pump. So that's just going to suck the air out of the bottle. You can see the marshmallows have already grown quite a lot. And if I just give it a little shake, because they get all a bit wedged in the bottom, we should be able to pump it all the way to the top. So we can have a whole bottle of marshmallows and we only had half a bottle. Now, there's a bit of a problem though, because if I wanted to eat these massive marshmallows, then I've got to take this lid off, haven't I? And when I take the lid off, all that air that I sucked out of the bottle is going to go straight back in, and then they're going to shrink again. Should we see? 1, 2, 3. And we've got little marshmallows again. So we're going to use this air pressure idea to actually launch a rocket. Now, this is a very simple rocket that you can make yourself at home. So I'm going to show you how to make it, and then I'm going to show you how you can use some chemistry to build up some gas pressure to launch it right up into the air. Now, you can make it inside, but launching is definitely going to need to be outside. So all you need to make it is an empty plastic bottle. 500 millilitre one is best, and if it's one from a fizzy drink, it's likely to be about the right size. You're also going to need a cork. Now it's really important the cork is the right size to fit into the end of the bottle quite tightly. And if it doesn't fit in tightly, it's just going to leak when we put the rocket fuel in and it's not going to work properly. You also need 3 or 4 bamboo skewers, or you can use drinking straws. If you're using bamboo skewers, it's a good idea just to get an adult to snip the sharp ends off first, just to make it a bit safer. So you can snip all of those off before you start. You also need 1 drawing pin, scissors and sellotape, and a tissue. Now the tissue is a bit thick. When it's 2 or 3 layers, you actually want to peel it apart, and we're just going to use one of those single layers on its own. You can, if you want to, add a nose cone like I have here. You could add fins on it to make it fly straight or look cool, and you can decorate it any way you want. But the main thing we just need is the bottle with these sticks attached. So you need to take your bottle and your 3 sticks. I'm just going to snip the ends off these ones. And you can attach them around the outside of the bottle with sellotape. Now I'm using 3 sticks. You can use 4 if you like, if you want to make it a bit more stable, but it's going to make it heavier. So you can play around and experiment. At the end of the day, we're scientists and that's what we do. So you're just going to tape the sticks around the outside of the bottle so that it can stand up just like this one. Make sure it does balance properly. You might need to change your sticks a bit if it's not. And as I say, then you can add nose cone, fins, decorations, anything you want to. Then we need a way to actually launch it. So we need some rocket fuel. Now, rocket fuel is just all about having something to push against. And we're going to do a chemical reaction for our rocket fuel. We're going to use some vinegar and some baking soda. Because when these 2 things get together, they make a whole load of gas called carbon dioxide. I'm just going to show you a little bit of the chemistry of how this rocket fuel is going to work. So for this, I'm just going to pop a tray in here because this one can get a bit messy. So I have a couple of conical flasks here. I'm going to put vinegar in this one. And then this one, I've got some hot water in there, and I'm just going to put a little bit, well, quite a bit in fact, of baking soda in there. So baking soda is also called bicarbonate of soda, and you find it in the baking section in the supermarket. Don't get the baking powder though, it does need to be bicarbonate of soda or baking soda for it to work well. Now, the reason that when these two things get together, some chemistry happens, is because of the opposite kinds of chemicals. So vinegar, oh that's very vinegary, is an acid. Now, scientists use a chemical called universal indicator to tell them what kind of chemicals they've got. So when we put it into an acid, it changes from being green to red. That tells we've got an acid. And when we put it into this one, it's an alkali, which is the opposite. So it's only a little bit alkaline. So it's going to stay fairly green, but it goes a dark green colour. So that tells us that we've got an alkali. Now, whenever we put acids and alkalis together, they're always going to do some chemistry, they're always going to have a reaction. Now sometimes that reaction is something not very exciting at all and you can't really see anything. But if our alkali is a special type of alkali called a carbonate, then when the two get together, we get some quite explosive results. So if I pop this into here, we can see what happens. Whoa! Now look at all of those bubbles. All that fizzing and bubbliness is actually carbon dioxide gas. And that's the same gas that we make in our bodies and we breathe out. And all of those bubbles of gas just escaped from there. Now imagine if we had that same chemical reaction happening inside our rocket, then it's going to build up that gas and it's going to try and push the gas out of the end. So the pressure can build up and build up until it can't hold it anymore, and then it's going to push it out of the end of the rocket, and that should mean that our rocket will fly up into the air. Now, I'm just going to clear this up a bit before I show you how to actually put your rocket fuel in your rocket. So we can use that vinegar and baking soda reaction to make all of that carbon dioxide, which will be under really high pressure and it will want to escape. So if you have that in the bottle and the cork's in there, it's going to build up that gas pressure until it can't hold it anymore. It's going to shoot the cork out and your rocket's going to shoot up into the air, which is brilliant. But there's a bit of a problem, because if we just put the vinegar in and put the baking soda in there, it's going to react so quickly that gas is going to escape before we could even get a cork in there. So that is where we are going to use that tissue and the drawing pin. So you're going to get your tissue, which we've already taken apart, so it's just a single layer. We want it to be nice and thin. And we're going to put some baking soda onto the tissue. And we're basically going to make a sausage of baking soda wrapped up in the tissue. Now, when you roll it up into the sausage, it needs to be thin enough that it can fit through the top of the bottle, because that's basically our secret weapon. So you can roll it up, fold up the bottom and pop a bit of sellotape on that just to keep it into its sausage shape. Check that it will fit through the top of the bottle. Ooh, this is quite tight, but it will just go in. And then you can pin it with the drawing pin to the bottom of the cork. Just like that. So now if this goes into the bottle, then if we have vinegar already in the bottle, then the two aren't going to meet. And until they meet, the chemistry isn't going to happen, the reaction's not going to start, the pressure's not going to build up, and it's not going to fire. So it's going to look something like that. Now that's all you're going to do while you're actually inside, because the next bit could go a bit wrong, so you want to be out in the garden or out in a field before it actually happens. So then what you're going to do is you're going to take this and your vinegar out to wherever you're ready to launch it. It's a good idea to protect your eyes as well, because sometimes when the rocket fires, it can spray vinegar around a bit. So I've got my safety goggles. If you've got goggles like this from a science set or something, that's brilliant. Otherwise, see if somebody at home has got some DIY goggles that you could use, or otherwise, even swimming goggles or a snorkel mask will work perfectly. Just anything that's going to stop that vinegar splashing into your eyes. So Once you're outside, you can open this up carefully. Make sure you're not making the tissue fall off. Ooh. And you're going to put some vinegar inside. Now just pay attention to how far down this sausage gets to, because you don't want the vinegar to come up any higher than the bottom of the sausage, because otherwise when you're pushing it in, your reaction's going to start too soon. So I can pour it in like that. I think that's going to be about right. And then, goggles on. And so do this bit outside, please. You're going to put that in like that. Carefully pushing it in. Really got to do it carefully so that you don't break the tissue and let the powder go in too soon. Then you're going to press it down nice and hard, like that, as hard as you can. If you've got a nose cone on the end like that, you're going to need to get somebody else to hold on to it for you while you push that cork in there, okay, because you won't be able to stand it on the table or stand it on the ground. So push it in as hard as you can. Then you take it outside, and when you're ready to launch it, you're going to tip it upside down. You're going to stand it on its, not like that, you're going to stand it on its sticks like that, and then you need to step away. As soon as you've got it balanced, walk away, and you'll see that reaction happening in there. You'll see the fizzing happening, so you know the gas is building up, and it will build up and build up and build up until it can't hold it anymore, and it's going to shoot into the air. Now, do be careful though, that if it looks like it's not going to launch, it probably still is going to launch. So leave it for a good while, even if you think it's not ready to launch. If it really isn't going to go, then you need to get a grown up with some goggles on to go back and deal with it, just in case it goes off when you're not expecting it to. So if you launch this outside in your garden or the field, it's a great idea if you can try and video it or take photos, and we'd really love to see what you've been doing as well. So do email them to us at emma@fabscience.co.uk or share them on the Fab Science Facebook page. And if you want other ideas of things to do over the summer holidays, there's loads of different science activities, experiments that you can try at home on the Fab Science website. We've got a whole section of science at home, and it's got instructions for things that you can do, and also the grown-ups of things that they might need to buy or collect for you. My husband. Yeah.